Hello everyone. In this particular lecture series on artificial intelligence, so far we have covered about different search techniques. That was the basic search technique, that is breadth first search, depth first search. From that we have gone to the most advanced search, heuristic search techniques, then local search optimization, and then we have covered different adversarial search techniques as well. Today we are going to cover a different topic, that is knowledge and reasoning. So let's start today's lecture. So what is the formal definition of artificial intelligence? Let us recapitulate some of the topics. This particular field of computer science and engineering is concerned with the computational understanding of what is commonly called intelligent behavior and with the creation of agents that exhibit such behavior. So that is the artificial intelligence. So it basically deals with the intelligent behavior and those agents that gives us or shows intelligent. How one agent can get or gather intelligent behavior. How the intelligence comes to the agent. That's the question. So the intelligence comes to the agent by the knowledge they gather by the day-to-day experience. Like if there is a hot pan in the gas stove, we are not going to touch that. That is going to burn our hand. So we need another thing to remove that utensil from the gas stove. We cannot directly touch it by our hand. So that burning sensation, if one day we have touched with our bare hand that hot pan that was in the gas stove, there will be a burning sensation in our hand. So that gives us the knowledge that with our bare hand we should not touch that. So if we acquire that amount of knowledge, then from the next day onward we are not going to directly touch that. So that is the intelligent behavior. So how the intelligent behavior comes to the agent? So earlier we have talked about this type of architecture for the agents, where the agents gather the sensory information from the sensors, and after sensing the environment, there will be some rules given to the agent. Based on the rules, the agent is going to take some actions on the environment. So it is gathering sensory information by the sensors and actions are taking on the environment by the actuators. So that means agents are getting knowledge by the sensory information and acting upon the environment, how the environment changes by that thing. That gives us knowledge to the agent. So this is how agents are gathering knowledge. So this is the knowledge and intelligence. That is gathering knowledge, agents become much more intelligent. So we are talking about knowledge and intelligence. So this knowledge need to be represented properly. That is, knowledge representation should be done. Otherwise that knowledge will be of no use to the agent. So this knowledge representation is a sub-area of artificial intelligence that is concerned with understanding, designing and implementing ways of representing information in computers so that programs or the agents can use this information. And how they can use the information? To derive information that is implied by it, to converse with people in natural languages, to decide what to do next, to plan future activities, to solve problems in areas that normally require human expertise. So in this way, information can be used by the agent. So information can be used to derive another sort of information. It can be used to talk with the people in natural language, that is, hey Google, what's the weather today? So that is the natural language we are talking to the Google. And based on the information collected, the next plan of activities can be decided. Also, if we can decide next plan of activities, so that means we can solve problems that normally require human expertise. So without human intervention, only the artificial agents can solve the problem. So that is the importance of knowledge representation. Now, the reasoning part. So reasoning is that deriving information that is already present in form of reasoning. Knowledge representation schemes are useless without the ability to reason with them. That is, you have represent knowledge very efficiently, but from that knowledge representation, reasoning cannot be done. So that means that knowledge representation is useless. Your knowledge representation should be in such a fashion that from that knowledge representation, proper reasoning can be done. So this is the knowledge representation and reasoning, KRR. Now, let us talk about what is the difference between knowledge and belief. So there are two terms. One is the knowledge, that is the agents are gathering by the sensory information and acting upon the environment. And there is another term, that is the belief, that we believe. So knowledge is the justified true belief. All the beliefs are actually not knowledge. But if the beliefs are justified and true, then that is the knowledge. So let us have one example. So some statements have been given to us. First statement is, Sally believes that the first player in chess can always win, while Betty believes that the second player can always win. And the third statement is, Mary believes that with optimal play on both sides, chess will always end in a tie. So there are three different statements, and in the three different statements, all of them are contradictory with each other. That it is not always true that the first player will win, same as for the second player, as well as it's not possible that every time it will be a tie. So one player will win, and which player is going to win, that does not based on which player started the game. It can be either way. So that is based on the three statements. If one game has been played or chess has been played, so one will be correct, that is one of them is correct, but none are justified. So that is the difference between knowledge versus belief. So as all the three statements, none of them are justified. But if one chess game has been played, it is true that one of the statements will be correct. Now, another terminology is background knowledge, that is some sentences and how we understand them. So what is that? In our day-to-day life, while we speak with another person, another human being, it's not that every time we are going to say the statement completely. Sometimes we say something that some portion of the sentences has been missing. But then also we are able to convey our message. Suppose, just take one example, that one statement is, John likes ice cream. So what does that mean? That particular statement means. That can mean that John likes to eat ice cream. So that to eat part, that is omitted from the statement John likes ice cream. But if I say someone that John likes ice cream, then the other human being can easily understand that John likes to eat ice cream. Same way, let us have another example. Bill flicked the switch, the room was flooded with light. So what is that? What the complete sentence should be? That is, Bill moved the switch to the on position, which caused the light to come on, which lit up the room Bill was in. So this should be the full statement. But whenever we are saying or communicating with other person, trying to give what we have seen, that is, we are not going to always say the full statement. Sometimes we omitted some portion of the statement. But then also our meaning remains the same. So that is the background knowledge we have. That if we want to switch a light on, the position of the switch should be on the on position. that we easily have from our background knowledge, and based on the background knowledge we easily understand the meaning of the sentences. That is the background knowledge. Now, another topic is logic. So this logic is the study of correct reasoning. It is not a particular KRR knowledge. So what is KRR? Knowledge, and this is already given in this, if you have forgotten, knowledge representation and reasoning. That is the KRR language. There are many systems of logic or logics. AI KRR research can be seen as a hunt for the right logic. Now, there are some properties of logical systems. Important properties of logical systems have three components: consistency, soundness, and completeness. What is consistency? No theorem of the system contradicts another. That is the consistency. That is, if there is a one theorem is there, then the second theorem should not contradict with the first. That is, no theorem of the system contradicts another. Another terminology property is soundness. The system's rules of proof will never allow a false inference from a true premise. If a system is sound and its axioms are true, then its theorems are also guaranteed to be true. That is, if one system is already been proven, then the axioms are true, then its theorems will also be true. Third property is that completeness. There are no true sentences in the system that cannot, at least in principle, to be proved in the system. Some logical systems do not have all three properties. There is one scientist, Kurt Gödel, that incompleteness theorems show that no standard formal system of arithmetic can be consistent and complete. So this is the properties of logical systems. Now, what are the specification of a logic? There are three terms: syntax, semantics, proof theory. So what is the syntax? The atomic symbols of the logical language and the rules for constructing well-formed non-atomic expressions, symbol structures of the logic. That is the syntax, that is the atomic symbols. Semantics, the meanings of the atomic symbols of the logic and the rules for determining the meanings of non-atomic expressions of the logic. And then third is proof theory, the rules for determining a subset of logical expressions called theorems of the logic. That is the proof theory. These are the three specifications of a logic. Next topic we have propositional logic. That will be talked about on the next lecture. So this is for today. Thank you everyone for watching this particular video and happy studying.